Hi, welcome back to Intermediate Algebra. Today we're doing section 2.6, Inequalities with Absolute Value. So we're going to look at absolute values here, and we're going to start by looking at what they look like with inequalities when we have them on a number line. From there, we're going to move into solving them, and so what you really want to kind of get comfortable with is the stuff I have here on this board. Because if you can understand what's going on with this board, we can do the problems. And so that's going to be really, really important here. All right, so here's how this is going to start out. The absolute value of x is equal to 4. Well, from the last section we did, we know that there are two possible values for x here. It can either be positive 4 or negative 4, and you can see that I've put them on the number line with a couple of dots. Nothing terribly exciting. But what happens when we move into inequalities? So let's come over here. All right, so here we have the absolute value of x is less than 4. So any numbers that work here mean that when we take their absolute value, we have to get a number smaller than 4. Keep in mind, if you put in a positive or a negative value for x here, you're going to get a positive value. So what works? Well, anything between negative 4 and positive 4 will work. We can't use negative 5 because as soon as we take its absolute value, we get a positive 5, and that's not smaller than 4. So only in between negative 4 and positive 4 work. This is one of those compound inequalities that we looked at a couple of sections ago. And so we can see that x ends up sandwiched in between negative 4 and positive 4. And that's going to be really important going forward. Anytime we have an absolute value less than a number, the stuff on the inside is going to be sandwiched in between those two things. Now, anytime the absolute value of something is greater than, so in this case we have absolute value of x is greater than 4, that means now we're looking for absolute values that come out bigger than 4. Again, anything that goes in there is going to come out positive. So 5 certainly works, that's way out here on the right. Negative 5 also works though, and that's way out on the left. So notice that with this one we get two distinct portions of the number line, the far left and the far right. We get these two intervals from negative infinity to negative 4, and then also from 4 to infinity. Again, this is one of those compound inequalities. This is the one that we looked at where we have two separate pieces. So this is what we want to keep in mind. If the absolute value is less than the number, the thing on the inside is always sandwiched. If the absolute value is bigger than the number, you always have those two separate disjoint pieces. And a lot of times people get those mixed up. So please spend some time, watching and rewatching this if you need to kind of get this stuck in your head. Because if you can get this into your head, the rest of it's going to go pretty straightforward. All right, let's see what else I have. Okay, so now let's start solving some of these. So here I have three examples really. Let's get started. My first one, absolute value of 3x plus 6 less than or equal to 18. Now, just like with the absolute value equations that we did before, we need to make sure the absolute value is by itself before we go on and do anything else. You'll notice that for all these examples, that's already the case. We'll do one in a little bit where that's not the case. All right, so here I have an absolute value, and it's smaller than a number. Remember, that's the inside part on the graph. Okay, again, if you need to, go back and watch the first couple minutes of this video and see that again. So what that means is that the inside of my absolute value is sandwiched in between negative 18 and positive 18. So this is one of those compound inequalities. This is one with three parts, and we're going to solve it just like we did before. So I subtract 6 from all three places, gives me negative 24 less than or equal to 3x less than or equal to 12. Divide by 3, and we end up with negative 8 is less than or equal to x is less than or equal to 4. So our solution set then in interval notation is from negative 8 to positive 4. We have brackets because both numbers are included. And we're done. So you can hopefully see that if you can get the idea of am I sandwiched in between or am I going to have those two separate parts that we'll see in a minute, then I can solve these. Okay, they're really not much different than solving the linear equations that you learned a long time ago. So you just have to be careful. The biggest problem people have with these is that they're just not careful. They don't take their time to set it up right, and all kinds of weird stuff happens. So don't let that be you. All right, my second example, absolute value of negative 7x plus 4 less than or equal to 16. Again, you can see I sandwiched it in between negative and positive 16. So So I started by subtracting 4, and then I divided by negative 7, and that got me positive 20 over 7 here, and negative 12 over 7 on the right. But here's the thing. These are inequalities, so if we divide by a negative 7 like we just did, we have to turn those signs around. Which is good, because if I left them the way that they were, if you just imagine for a second that those two were switched back around, we'd have a positive 20 over 7, smaller than x, which would then be smaller than a negative number. That doesn't make any sense. Positive numbers are always bigger than negative numbers, so it can't go that direction anyway. So we have to make sure that when we divide by a negative number, or multiply by a negative number, that we turn the sign around. So anyway, this time my interval starts at negative 12 over 7, goes to 20 over 7. But again, watch out for it, because it's backwards. So our interval needs to go from smallest to biggest, just like a number line. Make sure you turn that one around. All right, my last example here with the less than case is absolute value of x is less than negative 5. This one is about as easy as it comes. Here's why. Remember, absolute values always spit out what kinds of numbers? Positive numbers. Which means that no matter what you put in here for x, it is never going to be smaller than negative 5. Because when you take that absolute value, the smallest thing you could possibly get would be 0. You certainly can't get anything negative. So there's no way that this one works. It's just no solution. If you run into that, that's a great problem, because you're done as soon as you go, hey, wait, that doesn't work. So, all right, we have the other case now. That's what's going to be on the next board. We're going to look at the absolute value bigger than something. So hold on. All right, so welcome back again. Here we go. Now we're looking at the cases where we have an absolute value and it's bigger than a number. So I have just two quick examples here. The first one's probably the more important one, because it's going to show you how to set up every last one of these. The second one's kind of weird. So we'll get to that in a minute. All right, for starters, notice that this time I have the absolute value of, oh boy, you can barely see it. There's a minus 2 there, I promise, right behind that big bright spot. So the absolute value of x plus 6 minus 2 is greater than 7. Now, we said just a minute ago, and I'm going to say it again, we can only do this when the absolute value is by itself. So I need to get rid of this minus 2 that's hiding behind the big bright spot. So I add 2 to both sides, and that gives me the absolute value of x plus 6 is greater than 9. Okay? It will not work if you don't get the absolute value by itself first. That's always going to be your first step. So let's take a look at what we have. I drew the number line first here because I find that makes it a little bit easier to figure out what I need to set up to solve. So I drew a number line. We have 0, I put negative 9 and positive 9 on, and I know that the absolute value being bigger than 9 means things like 10, 11, and 12 work out here to the right, but also that things like negative 10, negative 11, and negative 12 work out to the left. The middle doesn't work, right? Anything in between, say negative 3, its absolute value is 3. That's not bigger than 9. So we have to be out on the ends every single time with these. But how does that then translate into something we can solve? Okay, so here's the easiest way to consider it. The arrow points towards the numbers that work, or another way of saying it is, it points towards the stuff on the inside that would work. So I set up the one on the right as 9, and then I put x plus 6 out to the right. It's bigger, right? 9 is smaller than all this stuff because that's going out to the right. So there's my first one. 9 is less than x plus 6, or in other words, x plus 6 is bigger than 9. We expect that one. The trickier one is the one out to the left. People always want to put the sign in the wrong direction for that. But again, if you set it like the graph looks like, the negative 9 here is at the right-hand side of that interval. So the negative 9 here is at the right-hand side of my problem, and it's the biggest thing in that interval. Right? The numbers out to the left are smaller, so here I make the x plus 6 smaller than negative 9. So we really need to get good at setting this up. Here's a hint, it sets up the same every single time. Okay? So if you can get good at this one, you can do them all. So I subtract 6 from all of them, I end up with x is less than negative 15 and 3 is less than x. And in interval notation, you can see I have negative infinity to negative 15, and then also with 3 to infinity. All right, so there you go. that's basically how these are going to work. Let's look at this last example because it's a little bit different. Here again, I have an absolute value. It's bigger than something, but again, just like the last example, the absolute value is not by itself yet. So I do have to subtract that 8 before I can do anything else. 2 minus 8 gives me negative 6. But that brings us to a really interesting situation. Absolute values always spit out positive numbers. Well, our absolute value is, we're asking what x values will make this be bigger than negative 6. Well, everything will make it bigger than negative 6 because since absolute value only spits out positive stuff, this happens everywhere. So our solution here is all real numbers, everything. If you want, you could write it as negative infinity to positive infinity, and that would be fine. Or you can just write all real numbers, and I'll take that. So anyway, have a great day.